Yeah, I think Josan and Arjun, I think you're only two guys today. I don't know whether uh, man Sundar will join because uh, Dr. Shanti is traveling. She says she has some conference. Okay, so what we will do is before we go, let me share my screen with the next one. So Josen was curious as to how we got this to this. This is yeah, right? Josen, how do I solve this? Yep. Hello?
So you're audible, sir.
I'm audible, right? Josen is there. I saw his name.
Yes,
Hello?
sir. Dr. Joseph?
Yes, sir. Now, yeah. Hello.
Yeah, you're able to hear me?
Now I can hear. Yes, sir.
Sorry. So this is one question which you asked. I thought I'll not do it, but since you are so enthusiastic, and we will do this. How did I get from here to here? See, these are the tricks. If I teach all these things, you will say I will rather write JE than do this PhD because JE is only tricks. Okay. Now, how do you solve this problem? So let's see. dC by dt. Okay. So is equal to 1 by V into R minus F CFT, right?
Yes,
So
sir.
this is the trick. You define one new thing. Let U is equal to R minus F of C. This is what we keep teaching in IIT. This trick.
Yes,
Okay.
sir. Yeah.
Now can you do it from here? You are going to tell me the steps. So now next step is du by dt. What is du by dt?
Uh, uh,
First differentiation of the first term dr. R is a constant. So
0.
0. Next one minus is there. F, that's a
F is
constant.
constant. So F into du dc by dt.
That's all. Okay. So in other words, dc by dt is equal to what?
1 by V.
No. From
Uh,
this, dc by
from
dt
this.
is equal to 1 by f. Sorry, that's 1 by f. Right? Hello?
Uh,
Yes, sir.
I didn't get the 1 by F part.
Yeah, I'm taking this to this side.
Okay.
So when I
Yeah,
take
got it.
it to that
Yeah.
side, it will become 1 by f.
Yeah, now got it. Yeah.
Okay.
Yeah.
Now, so minus 1 by f du by dt is equal to what? 1 by, I'm
V
looking at this one. So
yes,
1 by v,
into R minus
no, r minus is u.
You.
U. Yeah, 1
U.
by V U. Du by U. Okay.
Right?
Yes, sir.
So then, what's the next step?
Bring U to left side.
No, from here you can directly tell u is equal to
1 by
u naught e power minus f by v,
F by B. U.
T. Yes.
T.
right?
T. Yeah.
See, what have I done? I've done one trick and then reduced it to this thing which I know, period.
Yes. Right.
So what is u? Not. A t is equal to 0. But my u is here. A t is equal to 0, c is equal to 0. So what is
So
that?
R, just R.
Sorry. Hello.
Yes.
Yeah, I'm in a class. Yeah, I'll talk to you after 8. Anything urgent? Yeah. Sorry, guys, so that this queries on this thing. So U naught is equal to R, right?
Yes, sir.
So U becomes what? R into e power minus f by v into t, right?
Yes.
So what is U substitute here? What is that I want? I want C.
Yeah.
So I'm going to do that here so that I don't lose the space in this thing. So what is, so R minus FC is equal to
R into E raised to minus FB by T.
right?
Yes.
So minus FC is equal to minus R e power minus, sorry. Minus R, I'm bringing R this side,
Yeah. Plus
plus R e power that,
minus FB by T. Yeah.
right?
Yes.
So C is equal to, so this minus, I'll cancel it, and so this becomes minus.
Minus.
Okay?
Yes.
C is equal to R by F minus
Into
R by F
E raised to minus FB by T.
Correct. So what is C?
R by F into 1 by 1 minus E raised to minus FE by T.
Right?
Yes.
Understood the trick?
Yes, sir.
That's all is the trick. In all these problems, another 4 problems like this, there are other tricks. Everything is a trick. I don't want to teach this course as a trick course.
Yeah. Okay.
Then you will say that I am no more interested in this. I would rather go and write JEE rather than doing PhD. Okay, so I'm not going to do that. Right? Okay.
Yes, sir.
Has anyone joined? Anyone? Has anyone joined? No one joined. Richard? You see, Arjun, Srinivasan Josen, Dr. Sundar has joined. Dr. Sundar? No. So no one else is.
No, sir, I don't think so.
Okay. So is that clear?
Yes, sir.
This is a simple trick. Okay. Since you asked me, I thought this is not very difficult. No one
So,
will.
these are all specific cases, right? Like we cannot generally apply for anything. Right?
No. Not the tricks are not specific.
Okay.
There will be another problem where you will use the same trick.
Okay.
Right?
Yeah.
No big deal. You will use the same trick there also. There are other tricks.
Actually, this is better because Rajagopalan sir had given answer, but using integrating factor or something like she said.
Yeah, that is another trick.
Yeah.
That's what I'm saying. So this, as soon as I saw it, I thought this would be an easier trick than.
Yeah. This actually can wrap my mind around it, but that was entirely.
Yeah.
Yeah.
That's integral factors are there. That is another trick, but that is more difficult. So that's why as soon as I saw it, I thought that's not the way to do it. That's not the way in the sense that this is for you guys, it's easier.
Yes, sir.
Okay.
Yes.
So we'll not do further on this course, these things.
Okay.
But if you are interested, I've given you the book.
Yes,
all
sir.
the tricks are there in that book.
That book is actually pretty good for us.
Yeah. There are a lot of things in that book. Okay. But we are going to concentrate on physiology, physics, that kind of thing.
Yes, sir.
Okay.
Yeah.
So that you will understand. Now what is that you have understood? Hopefully, you understood what is a differential equation, right?
Yes. Yes.
Okay. So let us, what we'll do is we will look at further these things, examples from these differential equations,
Okay,
right?
sir.
We are going to uh, use the, so in other words, what I am trying, so what is the purpose? The purpose is that how to write a differential equation. So that is the purpose. Okay.
Yes, sir.
Now, let us consider more complex model. Okay, and then I'm going to tell you how to solve this in MATLAB. These are the two things which I'm going to do. Okay, uh, it's an important class, but unfortunately, okay, I'll teach you guys, and then maybe I have to repeat it in the next class. I'll at least teach till we get the differential equation. Okay, now uh, let us say that I'm going to inject a drug. Okay, let's say A amount of drug I'm going to inject. Right. So from there, it is going to travel. Now, uh, there's a transport of this drug, right? So maybe it goes to the plasma. So this goes to another compartment. I'll decide what are the compartments that we're going to put. Okay. So this is some drug concentration in plasma. Okay. I may skip some of the things, but we can make it. It's no big deal. We can make it better. So from here, okay, there is a drug elimination. Okay, the drug gets drug elimination or drug clearance. Now, when I put a dose, it's not that the complete dose is now utilized. Okay, there is an absorption of the dose. There's the absorption of the dose, which is called as absorption rate. As doctors, you know that it's not that 100% is going to get absorbed. Absorption, right? Now it goes to plasma. Then it goes into another compartment. Okay, so in the next compartment, let us say that it is C2. So let's call this as metabolite. It metabolizes. So it is, say, metabolite concentration at this place, right? So from this metabolite concentration, the drug actually goes into so drug goes into two compartments. So it goes to the tissue. And then it goes to, say, for example, uh, this is because Josen has done work in cancer. Let's say that it goes to tumor. Okay. And then the drug gets cleared. Okay. Now, let's put some numbers to it. So this clearance is usually indicated as CL, followed by two subscripts, 1, 0. Okay. 0 means it's going out of the system. 1 means from which compartment. So CL10 is the clearance. Now, what is this? This is a very important thing is there's always a big confusion. What is CL10? Okay, their clearances. It is the ratio between the rate of drug elimination elimination divided by the concentration divided by concentration. So this is the ratio which is used in pharmacology, clearance ratio or clearance. Okay, this is proportional to, so the rate of drug elimination is equal to CL0 by drug concentration. Is that clear? Okay, so we are looking at all of them are first order, which we had defined before. Right. So then we also have what is called as K01, okay, which is the absorption rate. K01 is the absorption rate. When I put rate, be clear that there is one time there. Okay, absorption rate. Okay, we will stop for a minute here to write down the first equation. Now, I have put a drug, intravenous drug. Amount of drug is A, right? So it's put in, put in the body. Well, we'll come to epidermis, how it affects the skin and all that. I'll say that it enters the body. A. Now, so what is the rate of absorption, dA by dt? Okay, is the first thing. dA by dt, or clearance of the drug from the site of injection. Okay, so in other words, at what rate does the drug decrease? From dA by dt, what is the rate from which it decreases? So this is minus, because it's going to go into the body. I'm looking at how much is going to go into the plasma, right? So it's going to be absorbed. So minus, so dA by dt. So the amount of drug is going to reduce. So that is why there is a dA by dt with a minus sign. Then rate is K01. Absorption rate is always with respect to or multiplied by A. So larger the amount of drug there, okay, the rate at which it is going to be absorbed is high. This is the first physiology. Drug amount, clearances depend upon the drug amount itself. Whereas dA by dt is proportional to A. That's why you have all this e power all the time. Clear?
Yes, sir.
First
Yes,
question. Sir. Arjun? Now, the next is,
yes.
See, these are all mass balance. Understand that. Now, because it enters into the first compartment, I don't consider, you can consider this as 0th compartment, okay? And this is the first compartment into the body. So, the next question is, what is the rate at which my concentration is going to increase in plasma with respect to time? This you may not, it's not bolus. It may be bolus, or it can be over a period of time. How do I write it now? So there is something coming in. Please note there is a dt rate. So my right hand side, every term should have rate in it. Okay. So I know one thing. It is coming at a rate. So it's like water flowing. You remember our water? It is flowing from here to here. So it is coming in at the rate of K01. Yeah, it's coming in. So this is positive. Okay. The rate of drug coming in is K01 into A. Now I want a concentration of this. How do I get concentration? Because C1 is concentration.
Yes.
C1 at time t.
Into time.
No, time is K01 itself has time, because rate at which absorption rate.
C1 of t.
No. C1 of t is what I'm The right side is d C1 of t by dt divided by volume.
Yes, sir.
Yes, sir. Yes.
So much of in 1 second K01 into A has come in to the plasma. Okay. So what is the concentration of drug in plasma divided by V? In fact, this is how they find out. Also, you can find out the blood volume. You inject something, a tracer, then you measure the concentration. You know how much amount you injected, from which you can find out V1. Right? This is the usual way of finding out blood volume, for example. Or else, how would you know blood volume? Suppose you want to know blood volume, what will you do? Inject some tracer, something. Find out the concentration. Period. So the first term is over. This is all. From this, you can find out B1. The concentration, you can find out. Clear?
Yes, sir.
Now, this is the rate at which it is going in. Then, there are two clearances. C clearance from 1 to 2. 1 to 2. So, another is going out. So, one is going out. Okay. One clearance is elimination from the system. Elimination, clearance from the system. Okay. Not that all the drug which goes into plasma will go to the metabolic, it will metabolite. So a part of it is only metabolizing. So C12 is the metabolic clearance. So there are two outward things. This fellow is going out, this fellow is going out. So can you tell me the second term?
Minus CL.
I had given you the definition. C clearance means.
So there is already time in there. So
Correct. Time is where. Please note that carefully.
And the numerators in the would be in the
Rate. Right. So what is the rate at which it is getting eliminated? CL10 drug elimination multiplied by drug concentration. No, drug concentration. What is drug concentration?
C1.
From
C1.
C1. Is that enough?
No, that's C second elimination also. Minus.
No. Wait. So this is the rate of elimination. But I am looking at what?
Concentration per elimination.
So what do I do?
Volume. No.
Yeah.
Yeah.
Right. Why silent? Don't understand?
So the clearance is actually rate of drug administration per drug concentration.
No. See now let's look at this equation more clearly. Okay. So rate of drug elimination, which is something like dA by dt, is equal to CL10 into C. This is C. Clear? But what do I want? I want dC by dt. So let's say dA1. So when I want dC by dt, rate of drug elimination, rate of concentration elimination is what I want. If 0.05 moles get eliminated or 0.5 moles get eliminated. So what is the concentration?
Concentration is amount of moles by volume.
Volume. That's what I'm doing here.
Yeah. Okay, right.
Yes, sir. Okay.
Right?
Yes.
Yeah.
Yes.
Then one more term. What's the second term?
So
CL
CL1 minus CL12
CL12
into C1 by V1.
into
C1 by
into C1 by
V1.
V1. That is the second equation. See, look, one, then second equation. Now we are now right now in this place. Clear?
Yes.
Now, metabolite is going to enter the tumor. Metabolite, some of them may enter the tissue. Okay, and some of them will go out. Okay, clearance out. Now, I want to find out how much metabolite concentration, how does it vary? Clear? So in other words, I'm looking at dC2 by dt, but we are going to stop for a minute this because I'm only looking at metabolite. Sorry. Shucks. So I'm for a minute, I'm not going to do this because the metabolite to tumor, I'm going to put another rule. So I'm going to look at only metabolite concentration. We are looking at what is called pharmacokinetics. Am I clear? I'll come that in a minute. Let us say that this is stopped. You're not going to. Drug does not enter directly the tumor and tissue. So there is another way. Metabolite doesn't. We will see that in a minute. How that I'm going to convert it. Okay. Now let's look only at when I'm stopping this. To say so dC2 by dt. So what is coming in? CL12.
C1 by
CL12
C1 by V1.
into C1
Hmm.
divided by C1.
V1.
That is what has come in, but not V1. Now it's
Oh,
coming to
V2.
V2
V2, yeah.
minus fellow is going out. CL from 2 to going out of the system into C2 divided by
V2.
V2. So let me bring all the equations together. So there are 3 differential equations. What is the order of the differential equations?
1. First order.
first order.
First order. Clear?
Yes.
So, but we also noted one thing. We want, what is that we want? We also want the initial conditions. Right?
Yes.
So initial conditions at A0, write it here. So initial condition A of 0, that is a drug. I'm going to give a dose. There are various ways in which I can give a dose. I can give a dose as a bolus, some dose, we'll come to that equation. Clear? And
Yes.
let's say that the drug is first time given. So there is nothing, 0. Clear?
Yes, sir.
Now, this drug concentration, metabolite concentration, is what is going to kill my tumor. That's what it is. Okay? So there is, in other words, the drug effect is called as pharmacodynamics. ED, pharmacodynamics. Okay, you remember we read one equation, very important equation. Function actually rather, an equation or a function called Hill equation. You remember that we did this. It's core equation for the for pharmacodynamics, and in fact, that's how the drug reacts. So let us say that E is the drug effect. We'll see what drug effect is in a minute. So E, I'm going to write down the Hill equation which we wrote long ago, is equal to E naught plus or minus E max into C power X divided by E C X plus C power X. So this is the well proven, slightly complex equation. So X is called as the power value. Okay. E max is the maximum drug effect. Okay. Then there is 150. I'm sure all of you know what is called as, let me go to the next one. The CC50. In fact, today, Dr. Karthik was talking about this. Is he there? I don't think he's there.
No, sir.
The value, what is this? Any of you guys done
half-life concentration?
Yeah.
No.
Yeah, the value at half maximum effect. Half-life is slightly different. Half maximum effect is achieved. Okay. Now, the problem is, I can't use this straight away, because what is that I need? I need to know how the tumor is actually reducing. Okay. Tumor growth rate is what I'm interested in.
So, like volume of the tumor.
Volume of the tumor growth rate, or no, volume, ultimately the volume of the tumor. How does it vary? Okay. How is tumor going down, growth, and so on. So there have been very interesting studies on this. Okay. And so this is nothing to do with this course. This has been given to you already. Okay. It's been given to you. So in other words, I am looking at how much I'm going to kill the tumor. It's called K kill. How much I'm going to kill the tumor. Okay. Which is called as drug induced tumor decay. There's been papers on this, and in fact, this is what is very important, rate, obviously. So this is what many drug companies are interested in. What is K kill? Okay. Now, let me get this equation. So K kill is equal to actually, okay, E. Because that is what is going to, drug effect is means how much of tumor induced decay rate is there. That's what is drug's effect, right? Both of them are the same. So I'm expressing it in a different fashion. So K kill is E. And base value E naught is base value, which is not going to kill anything. Nothing is going to be killed. So that's 0. E max is K kill max, maximum amount, that is going to get killed. And of course, KC, same thing, EC 50% effect is equal to KC kill 50. So that K kill is equal to K kill max into some function of C2. In this case, I have put C power X, some function of C2 divided by, it can be C power X or something else. It can be a constant multiplied by C and so on. K C kill 50 plus some constant C2. I mean, some plus some function of C2. So usually there are various models. Usually this is equal to some capital K into C2, constant. So but research tells you what is that function. So now, though it's a simple model, you can make it quite tough, quite difficult. So we are looking at this left-hand side of this left-hand side. Here, now, what is the effect of the drug on the tumor? Now, the right-hand side, what is this right-hand side tissue? It is a safety of the drug, right? It is a safety of the drug. So for that, I should have another equation on the skin tissue, the epidermis. So there is a set of differential equation again, which gives me the effect on the tissues. Okay, so this again has come out. Epidermis itself has a 3. So it's going here into the tissue, the metabolite, and so that is, in other words, there's a metabolite concentration into the tissue. So that itself, interestingly, has a model which consists of 3 compartments. So what are these 3 compartments? Let's just write down the 3 compartments. I know it may become complex, but I just want to show you overall picture. I'm not going to solve them immediately now, but I want to show you the overall picture of how actually mathematics works. I'll stop for a minute and I want to take questions. Arjun or Jocelyn?
So the K-kill equation is derived from the Hill equation.
This equation.
Yeah. Yes, sir.
Yeah.
The K-kill equation is the.
Yeah. So this equation comes from here.
Okay.
Okay. And the connection is by a number of papers are there to connect it.
Oh, okay.
This would vary from, right now I'm just putting a simple thing. You can actually write down another equation for this. If you look at, there are papers which talks about dn by dt, where n is the number of cells. How does dn by dt vary? Okay, you can make it more and more complex. That is the whole research is all about.
Oh, okay.
Okay, and then I'm not going into that because just I'm telling you how things work.
The function of for K-kill max multiplied by function of C2 is just C2, right? You written f of E. Does that mean the E also is there?
No. This is
just the X function, C function, right?
The function E is a function of, this is a function of C2.
Okay.
C2. It can be C power X, C2 power X, or it can be just K into C2, whatever it is. This is a function.
So like
Okay.
f of x. Okay.
Some f of x. That's all.
Okay. I thought I saw E. I thought E also is somehow related to.
No, this because it is. I'm replacing E there. E max into C power X. I'm replacing
Okay.
it.
Okay.
So I'm just putting it as a function.
Okay.
All the drug companies are interested in that. You know, what is that function?
Okay.
Yeah.
Yes, sir.
So now let's stop for a minute before I go into another set of differential equation. Now look at this. If you look at only these two, let us forget about for a minute safety tissue. So what does that has happened? A set of differential equations. We have that here. Okay. Is now, this is differential equation, is followed by, this is an algebraic equation. So this is an algebraic equation. There's no differential there, algebra. Just an equation, just a function. Clear?
Yes, sir.
So actually, if I want to find out whether this drug will eliminate the cancer or not, actually I have what should I do? I should solve this differential equation and solve the algebraic equation. In fact, they are together, because the C is nothing but C2. That's going to come here and sit here. Is it confusing?
No, sir.
No, sir.
Yeah.
No. Yeah.
Yeah.
So the drug effect would obviously come from the metabolic concentration. Yeah. So.
Metabolic concentration. So I'm putting that here. So actually, this is called as differential algebraic equation. You know why I'm so confident in writing this? Because I teach a course on vehicle dynamics, and we do a lot of work on motorcycle dynamics and all that. My friend is there. Srinivasan is there.
Yes, sir. I'm here, sir.
Yeah. So Srinivasan, what we solve for vehicle dynamics is what these guys solve for pharmacokinetics and PK/PD, period. Okay. In fact, our equations here are more difficult than these equations, and our algebraic equations are also more difficult.
Yes, sir.
But if you solve this, you get more money than dynamics. So it's better that you also shift from vehicle dynamics to PK/PD.
Yes, sir.
Okay. Joseph, I'm telling a secret to these guys. Most of these pharmacology guys don't know much maths.
That's true, sir. I worked in a pharma company. I didn't do anything, and I was making a hell lot of money. So
you are an amazing character, man. You left that and joined a PhD.
yeah.
So do you know that most companies, because I've talked to Pfizer, PK/PD is not their strength. They usually subcontract it or buy another company, because many of those chemists don't understand this PK/PD. It's not that I've made it very simple, but this is the fundamentals. And in all our professions, we keep solving DIE, differential algebraic equations. That's exactly what I have done now. Then I have another set of equations. Right? So another set of differential equations. Another, so to the right hand side. So left hand side is given me algebraic equation. And the right hand side will give me another set of differential equation. Clear?
Yes, sir.
So when it comes to tissue, so I'll just yeah, and remove this. Oh, wrap around thing. Okay. So so here enters my metabolite concentration into the tissue. Right? So that concentration is uh, is going to affect the birth rate of the epidermal cell and all that. Okay, so I have three compartments. What is called as proliferative compartment. I'll call it as proliferative. It's just standard. I'm copying also only from textbooks. Then differentiated compartment. Then stratum corneum or SC, the topmost. Okay, so I'm going to just, so this is how it goes. Okay, so similar here again, mass balance, that's all, nothing more. So this is how we use or we can solve the I mean, this is how you write down the differential equations. Clear? First thing. Okay. Now, how am I going to solve it? I'm not going to break my head in solving it. I have MATLAB solvers for this, so there is no problem for me. Okay. So fundamentally, the process is that I write down. So I'm going to do a set of equations. See, this will be the subject for the next topic, but nevertheless, now I have three equations. Let's only concentrate on, let's epidermis, that will for a minute we will leave it. We'll take these three equations only. Okay. Now, when I have these three equations, you can see there that in the three equations, d by dt is common, but I have A, C1, C2. Clear? A, C1, C2. So I can write, note this carefully. A, C1, C2 on the left-hand side, and A, C1, C2 is also on the right-hand side. Clear? I'm going to group them now. I'm going to group them. So I'm going to call this group as Y. So Y has three things. A, C1, C2. Okay. Textbooks write it as bold letter of Y. I'm going to put one squiggle at the bottom. So when I put a squiggle at the bottom, it means that there are three, not three, that this is called as a vector. So there are more than one. Let me put it like that. There's more than one. Okay. So now this left-hand side of this guy, the left-hand side of that guy, I can write it as dy by
dt.
right? Because now it is going to operate on every fellow. This means I'm telling you that there are three equations. Clear?
So, sir, does this mean this dy by dt is simultaneously acting on three equations?
Yeah. So now,
Okay.
so this is d a c1 c2 by dt.
But okay, makes
So
sense.
this means dA by dt, dc1 by dt, dc2 by dt. Right?
Yes, sir.
Understood?
Yes, sir. Yes, sir.
Okay. Now, let's go back to the left-hand side, the right-hand side. If you look at right-hand side, there are actually three functions. Can I call this as there's one function here, another function here, another function here? Right? So I can call them as F1, function F1, function F2, function F3. Okay? So I can say that this dy by dt, which is what I just now wrote, dA by dt, dc1 by dt, dc2 by dt, is equal to function 1, function 2, function 3. Right? There are three functions. They are actually function of t and y itself. It may or the coefficient can be 0, doesn't matter. Let me, without confusing you, let me say that first, one more step I'll write. Function of a, comma c1, comma c2, t, comma a, comma c1, comma c2, t, comma a, comma c1, comma c2. There are three functions, isn't it? So this function is the first function. This one. This is the second function. This is the third function. So together, so this is a column, one column of numbers or one column of functions. So it's called a vector. So function vector, this vector. So let me call this vector by the same way I did here with the squiggle at the bottom. T, comma, y, right? All mathematicians are lazy. They don't want to write the full equation. This full equation, no one writes like this fully. To note, I mean, once I write it, I will just simplify it. So can I write all the three equations like this? Right?
Yes, sir.
Yes, sir.
That's all. So where this y t naught at t is equal to 0 or t is equal to y naught. What was y naught? You remember a 0 0 actually. C1 0, C2 0, a. This is what we saw right somewhere here.
The initial condition. Yes.
So that's initial condition. So you learned a very important concept called expressing it as a vector. Clear?
Yes, sir.
So this is all. What is the order? First order differential equations. So they are ODEs, ordinary differential equations. because there is something called partial differential equation. I'm not going to be worried. Fortunately, 99% of the problems are ODEs in your case. Clear? Now,
I
this
just
is
have
also
before you move on. I just wonder the function 1, 2, 3. Is it the entire function or if you go back? Okay.
Yeah. So
Because
yeah,
the first function is the same. First part of the second function is same as the first function, right? The K0.
that doesn't matter. That doesn't matter.
Okay.
That doesn't matter. This,
Okay, fine.
this whole thing here is F2.
Okay. Okay. Sense.
Right?
Yeah.
So this whole thing here is F3.
Okay. That's fine.
Right. Where am I? Okay. So ordinary differential equation. Now this is explicit. Remember we talked about explicit and implicit. So this is called as explicit ordinary differential equation, explicit first order ordinary differential equation. You learned a big thing. Okay. Sometimes we have partial differential equation. Of course, it is there in many more advanced things in physiology, but I'm not going to cover that now. Okay. Clear?
Yes, sir.
So now what I'm going to do is I'm not going to solve this straight away like the way I did this. That's going to become more and more difficult. Okay. I'm going to solve it by using what is called as numerical means. Right? I'm going to solve this in terms of numerical means. Now, I'm going to, instead of being very rigorous, I will get to a very simple thing as to tell you what is a numerical mean. What is numerical means? Okay, it's available in your book, but I will not go into too much of details because we are not going to do that. My good friend MATLAB is going to do. So I'm not very worried about the actual case of
Numerical. Yeah.
numerical equations. So can you guess what we are going to do? Can you guess it? Suppose I have an equation, okay, where I'm going to write dy by dt. This is not numerical, is equal to, say, some constant k. I want to solve it numerically. Numerically, I know you know the equation, but I want to tell you that I want to solve it numerically. Can you tell me how you can solve it?
Plotting graph.
No, I can write dy to be y2 minus y1 divided by t2 minus t1. Because after all, delta t, what was this? This was nothing but
delta y by
delta
delta
y by delta t as limit as delta t tends to 0. This is what it was.
Yes, sir.
Okay, that is y2 minus y1, t2 minus t1. T2 minus t1 is very small. That's all.
Yes.
Is equal to k. So y2 minus y1 is equal to k into t2 minus t1. So y2 is equal to y1 plus
K into
into
T2
t2 minus t1. Simple. That's all. Okay. But now this is only one simple step. So I will go to now y2. I know given y1, I know y2. Right? So let us say that I have some curve like this. And so from this, let's say that for generic term, no, I'll don't think. So I'll say that y1 is actually 0. I'm starting from 0. Okay. and 2 is actually 1. It's actually a constant, so I should be careful in drawing this graph. So I'll just put it like that. So it can be anything. I don't care, but it's so simple to, K is simple to show, that's all. Y1 is equal to Y0 plus K T1 minus T0. Correct?
Yes.
So what have I essentially done? This is T, this is 0. So this is T1, right? So now I have got Y1 from this. Given T1, this equation will give me Y1. So I got this Y1, this point. Correct. The slope of the line is K. This is what is given, from which I go. Now, from here, I will take T2. So that I will get Y2. How do I write Y2 now?
Y1 plus K into T2 minus T1.
That's it. So now I know, because I know T1 and I know Y1, Y2 is known.
It's similar to that equation we did before, like M with drug.
Correct. Remember, we did that. So now what I am doing is I am tying that to this. The difference form, finite difference form, right? These are finite difference equations. So look, so that what we did before can be now used to solve this equation. Clear? So in general, I can write down. So this is, I mean, there are a number of names I can write down. Now I'm going to go back to my good old, this vector. So I can write down in general y, okay, say 1 is equal to y naught plus that k, okay, into T2 minus T1. Usually the language is to call this as h, where h is equal to T2 minus T1. That's all. So K can be anything. K can be very complex, more complex than this. Doesn't matter. Some K into H. So if you want to make it more complex, it can be some function T naught. That's what we wrote, no? T comma Y. It can be that. So T naught into Y naught. So this function is evaluated at T is equal to 0 and corresponding this equation, Y naught. So T naught, Y naught into, so, sorry. Y1 is equal to Y naught plus into H. Correct? Is that clear? Now, what is Y2? Y1 plus
into T1 Y1.
Brilliant, man. I think I can earn more millions. So now you know now you know, you're a doctor, knows physiology as well as maths. No, that combination is very rare. Brilliant.
Yeah.
Arjun, understood?
Yes, sir.
Yeah. So think about whether you want to practice or you want to go here, because he wants to practice. Okay. Is that clear?
Yes,
So T1 is what? T naught plus H, actually. That's this equation. T naught plus H. So now I've got Y2. From Y2, I can go to next step, Y3. I can go, so I can keep going. Y1, Y2, Y3, and so on. Clear?
Yes, sir.
Why I'm not going to rub this anyway. So you can keep going like that. Okay. So in MATLAB, this is only the easiest. This is called Euler equation. This is called as Euler equations. But Euler equation is old as 1700s. But there have been so many things after that. And one of the most famous way of solving. Now, what is the difference? The way I have written it is too simple. Okay, there are a lot of disadvantage with this. So there are other ways of writing the same finite difference form, other ways of writing the same equation. I'm not going to write it now and scare you, but anyway, there are other ways of writing. I need not even say that. That's the advantage. So there are two guys, Range Kutta, the guy called Range and another guy called Kutta. They came out with a scheme, a numerical scheme. In fact, a set of schemes, numerical schemes. Okay, which is called as Range Kutta methods. Okay, now should I learn that? No way, no need, because this whole thing is implemented in MATLAB and is called as ODE. Remember, ordinary differential equation. So there are various order of this Range Kutta and other things. So they call this as ODE 45. This is the function which will do this Range Kutta method. Okay. Apart from that, there are a number of schemes which will solve. Given this equation, hey, ODE 45, solve it, it will solve it for you. And give you all this Y1, Y2, and so on. So there is another called ODE, written as ODE 23, ODE 15, yes, and so on. So there are a number of schemes like this, okay, which will actually solve these equations. Okay, now typically, how does this look like? How does this, I mean, in MATLAB, how does it look like? Very simple, the syntax. I'm going to write the syntax. So T, comma, Y. So it gives time. Y1, Y2, Y3 is with respect to time. Y is equal to ODE 45. Okay. And the function, that function, where is that function? This function. So this is, so I have to define the function. So at function means I am referring to that function. Okay, comma, T0, comma, TF. It can be 0, starting value, final value, comma, Y0. That is the initial values. So this is a vector. Note that this is a vector. This is time. This is the calling function. This is the function which we have looked at, T0, TF. Clear? Any questions?
So T naught TF means the function at time 0 and function at time t. Is it like that?
T0 means how much time, say from 0 to 50 hours or whatever it is.
So T is time only. Okay.
Time. Both of them are time.
Okay. Y0 is the function part. Okay, got it.
Okay.
Yeah.
So that is the this one. So we will we will look at one compartment model just to understand how this is done. Okay. Uh, let me tell you what is this thing here, and then we will we'll go to our ODE and see how we can do this. Okay. So let us say that I'm going to take only one equation. One equation is written as dc by dt. Okay, one compartment. Okay, so which is R of t is the dose divided by V minus the clearance term into C divided by V. I'm only looking at only one equation, right? So R of t can be intravenous, so which means that it is given over time, dose divided by a time. Okay, when time is, what is this symbol?
It's a
Belongs
member of
Member of
belongs to.
0 to TR, between the two. And this is T is greater than equal to TR, the fellow is 0. Understood? What else I need? I need initial values. Let us say that initial value is equal to 0. Clear? Okay.
The zero part I didn't understand. 0 and t greater than tr.
Which part? This part.
The r and t. The above
This part.
the second one, the dose by tr,
Yeah.
and that equation.
Yeah. So rate at which you are giving the infusion.
Yes.
Rate at which you are infusing. Okay. So suppose 200 mg. This is the example. 200 mg of drug you are going to give.
Yes.
So the 200 mg of drug, you can give it at a time TR, say 2 hours.
2 hours. Okay.
So the rate is what? Is equal to 200 by 2 for 2 hours. After 2 hours, 0.
Oh, okay.
After 2 hours. This is how mathematically you write what you tell. Orally in English, you say this. This is mathematically you write it like that. Okay. Now, very subtle difference is not important, but if TR is included here, I'll put a square bracket. If it's not included, it's exactly at 2 hours, just before 2 hours, 1 hour, 59.9999 minutes, you stop. Then it is like this. So in other words, I can put a square, don't worry too much about it. I can put a square bracket here, and then I have to say T is greater than TR. After 2 hours, that's what is greater than TR. Is that clear?
Yeah. So this means that it becomes 0 only after 2 hours, after tr.
After 2 hours, after 2 hours.
Yes.
Okay. 2 point, not 1 hour. This is what it means. Or it can be, if I put greater than equal to, if I put like this, then say TR can't be at 2 places. Mathematically. Loosely, you can say, give it for 2 hours. So is it exactly I should stop at 2 hours, or I should stop at 1 hour, 59.9999 minutes is a mathematical question. So in that case, square bracket should not be used. I should put it like this. So these brackets have meaning. When I put a square bracket like this, the boundary is included. When I put square bracket 0, 0 is included. When I put parenthesis, then 0 is not included. This is mathematics. So 0 comma t, if I give it like this, strictly speaking, it is between 0 and t, but 0 is not there, t is not there. So if I now draw a line for 0 to t, then this means I'm going from very close to 0 to very close to t. That's what it means. 0 and t are not included. But when if I put 0 comma t, and I now draw the same thing 0 to t, then 0 is also included, t is also included. Yeah?
Yes.
Subtle difference.
So when TR
Yes.
is included, then the T would be greater than TR.
Exactly. Because you can't have, in 2 hours, you can't still give the dose and make the dose 0. That's not
Zero.
possible.
Yeah. Yes. Understood.
That is why. Understood?
No, understood, sir.
Yes, sir. Yes, sir.
Okay. Now, that's not, uh, there is one, so the infusion rate is what you are interfering into the system. You are giving this as an input. Okay. So drug input. You are forcing the drug inside. Okay, note that carefully. So it is an input. R of T is input. Many people write this as U. All engineers write that as U. Input means U. See, these are, okay, what's the big deal? No big deal, but that's how people write it. I can't help it. That's all. Okay. So give me a second. I'm going to go out of this and I have to show you before we finish the class. I'll show you MATLAB code for this. Okay. So I'm going to
Yes,
go
sir.
out and I'll join you from my computer. Are you able to see my screen?
Yes, sir.
Yes, sir.
Hello?
Yes, sir. We are able to see the screen, sir. Are you able to hear us, sir?
1 minute. Are you able to see my screen?
Yes, sir.
You're
Yes,
able to
sir.
hear me,
Yes.
right? Yeah. So let us look at slightly more involved, but doesn't matter. I'll repeat it in the next class. So there are two things that are important. Remember my equation. Sorry, I'm not able to project both. Okay. There is a volume. Okay. There is a quantity called clearance, CL. Okay. Now, P dot V means I am going to call this vector. I'm going to now define a vector consisting of V and CL. Remember the vector? So there are two entries in the vector. I think I should have done that before. Okay, anyway, I'll repeat it in the next class. V and CL. So P dot V means there is a vector called P whose first entry is V and its value is 12.6. There is a vector called, the same vector P has another second entry called CL. You remember we had A, C1, C2. Like that, we have V, CL, so 2.16.
Yes.
Clear? Right? Now, this is, I'm calling the differential equation with the Range-Kutta method, ODE 45 at derivatives. This is the function. I told you that's the function. Okay. And I'm going to do this problem for time 15. That's the next one. So I'm going to solve this. So T naught TF. T naught is 0, TF is 15, and the H value, T2 minus T1, which is delta T, is given by 0.01. Okay. And I'm sending in, these are the initial value. When initial value is 0, and I'm going to send the value P. And I mean, there's one more thing. Let's forget it for a minute. So now I'm going to call this, and so derivative. So the derivative is dc by dt is this function. You're able to see this. So that's the derivative function. Okay. And I am also defining in that this function called RT also. Okay. This T less than 2 means that it is less than 2. This is 200 by 2 is what is being applied. So this here gives me dc by dt, my first equation. Then the function here gives me the RT equation. This two completes it. This guy goes here. Okay. And now this guy, one line gives me both T and C. Clear? Is that clear? What have I done? I have nothing. This equation I've written here, and the solution is by one line. And then I have all these things I'm going to plot. So let me run it. So this is the result. So infusion, I've plotted infusion and concentration. So infusion is a constant till 2 hours. 200 by 2 is 100. So 2 hours. And then I'm not giving. So the concentration in my compartment keeps on increasing till 2 hours. But then when I have stopped, that's going to go down. Okay. So this is the concentration with respect to time. And I've solved this differential equation using a numerical analysis called ODE 45. Is that clear?
Yes, sir. Yes.
Okay. So we can keep writing. I mean, I'm not going to go into writing now. So this gives you the first hint. You can do this in ChatGPT, no problem. You can write down these two equations and tell that in English, it will write down this equation. But I thought I should also expose you to as to how you can write. I'll share these codes with you, right? So
Okay.
that will be useful to you. Okay. Any questions?
No, sir.
Okay. Now, I'm going to talk a few things, and then maybe we will do that in the next class.
So you
How
already
many-
defined the vector P before.
Yeah.
Okay.
Right here. Right. Yeah. Now, there is a problem in many of these drugs. In this drug, the concentration started increasing immediately, right? But in all your drugs and how the body reacts and all that, there is always a delay. Okay. Now, there is no delay here. So there is a delay because it's actually kinetics. It is going from one compartment to the other. I've just assumed that it is tuck, 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 it's going. But there is always a delay. So the equation has to be modified to introduce this delay. They are called as delayed differential equation, TDE. Instead of ODE, physiology has delays, and hence the equations are called as delayed differential equations. So what is this delayed differential equation and how do I solve it? No big deal. Similar way. Right? So I'm going to do that in the next class. What is this delayed differential equation? So I'll stop here and we'll do that in the next class. Okay?
Yes. Okay.
Okay, then. Okay.
Yeah. I will send you these notes. What I did this today so that you have a look at it, and we'll continue in the next class.
Yes.
Oh, thank you, sir.
Okay. Thank
Thanks.
you. Thank you.
Thanks.
Thank you.
Is
Thank
it
you, sir.
okay? I mean, are you able to, Arjun and Justin, you're able to
Ah, yes, sir.
follow?
Yes, sir. Yes, sir.
Yes,
This,
sir. Yes, yes, sir.
today was, I guess, the most, till now, it was the most interesting class. I mean, like, difficult, but interesting. Yeah.
Yeah, so you have to
More tips for profession now.
Yeah.
more, pardon?
More tips for formats. I didn't get the term properly, sir. Sorry, sir. The equations that you told today.
PKPD,
EKPD, yes, sir. Yeah.
pharmacokinetics and pharmacodynamics.
Yes.
This Teja, Srinivasan and all this, if they know it, I think they will leave tires. I'm a bit worried. I should stop Srinivasan from attending this. They will, no, waste of time. Sir, this is much easier and I can make more money means they will go there.
Money is there, sir. That's a fact.
Yeah. Okay, good, great. We will
Okay.
continue with this for some more time.
Okay.
Yeah, thank you.
Thanks.
Bye.